Yes. It's up on Facebook, going on Twitter now. It's on Twitter.
Take out of that, yeah. Raw output, you need to start the speakers.
Should be muted. Let's find out.
You need to start up the speakers globally. I have put it on Facebook, yes. Maybe a multi-pass.
How's that?
I just say no.
I think you're already.
Hello.
You're muting everything I can. Yeah. There's nothing left.
Hello. That may be better.
That might be getting better.
Yeah, all I did was shut down the computer sound. Yeah, I had to shut down all my different sounds. Something was getting through.
Yeah. All right. So we're starting the last couple of talks now, and so we have James Patterson and Hamish Willey giving us a Mavlink update. Over to you.
Right, so before we crack into the Mavlink update, which we'll do in just a second, just an announcement for the last session that's coming up this afternoon, which is the dev team panel discussion. So for anyone out there on YouTube or in the room, just put a message either into the YouTube chat, the Discord chat, or the whiteboard that's up here at the front, just to start collecting topics and questions for what people want to hear from the dev team about, so that we can spend the next session after this one coordinating out ready for the last session. Cool. All right, so I would like to thank Andrew for scheduling me for the first session after lunch on the last day, for what is probably the driest topic we've got all weekend. Challenge accepted, I guess. What we're not going to do is try to make this over too exciting. It's Mavlink. It's important, but not exciting. And Hamish and I will just basically step through how we manage Mavlink at the moment, where we want to take it, and kind of the journey in between, with just a bit of a 101 overview of Mavlink for those listening in that kind of perhaps wonder why there is so many rub points within Mavlink and why it can be a bit of a challenge to wrap your head around. Right. So leading on from that, basically this is just the quick overview. How Mavlink is managed much like ArduPilot through development calls, pull requests into GitHub. The core management team for Mavlink Common, if you like, is basically Hamish and myself and Julian O's. Conveniently, we're all in very similar time zones. But basically every second Wednesday, I race home from work, we sit down, we do a dev call, and work out what's ready to go into common, what's still waiting for implementations or requires further testing, and gather the community feedback via issues or comments on those PRs to kind of figure out where the shortfalls are and what direction we need to take things. That's very much how Mavlink is managed at the message definition level, particularly within common.xml. What's worth pointing out here, though, is that Mavlink is really two very separate parts. One is those message definitions, be they common.xml, ArduPilot, mega.xml, or any of the other dialects, but it's also the tooling. And what I'm not going to spend time on today, mainly because I'm not the right guy to be talking about it, is the tooling behind Mavlink. And it's really the tooling that defines what Mavlink is as a communications protocol. So PyMavlink, which contains the schema for the Mavlink messages, plus all the generators for the headers and how Mavlink is actually applied, all of that sits within PyMavlink. And that's managed within the ArduPilot project, primarily by Tridge and Peter and a few others, such as Amilcar, who looks after the schema and tries to coordinate up and down. So if there are any questions that relate specifically to PyMavlink, we'll perhaps save those questions to the end, and I'll throw Peter or Tridge under the bus. Right, Mavlink 101. This is just most people in this room probably know all of this, but we'll just step through it. So that's the general overview. For the developers, there's some links. The next slide is kind of what I wanted to talk to.
Can I just stop for a second? The reason I put this up is because I have a slightly different in my head story of how this is going to be, is that you'll notice there are links to the wiki about what's supported and what's not supported. Later on, I'm going to talk about some of the pain points of Mavlink, and that's one of them, not knowing what's supported all the time. So that's where you find out within ArduPilot what works and what doesn't.
Yeah, exactly. So just because a message exists or is defined doesn't mean it's used, which is kind of that point there, and that could cause challenges or frustration. Right. Mavlink does two key things. And they're very, very different use cases and drive different design decisions and have different challenges. And you'll find that some of the inconsistencies in Mavlink are basically driven by the conflict, I guess, of what these two use cases are. So the one thing that Mavlink does, that only Mavlink does, is provide your telemetry stream to the ground station. That's a bidirectional link, but the nature of each direction is fundamentally different. In that the vehicle is basically just advising your ground station of state, just relatively low rate updates of what the vehicle is doing and what it knows about itself. In the other direction, coming up from the ground station, you're primarily giving commands or updating emission, that type of thing. What both those things have in common is that they're relatively low rate. And they are usually via a radio link, which is quite often an unreliable or lossy link. That drives some particular, I guess, conditions within Mavlink, and one such as resending or acknowledgements that enable Mavlink to function reasonably well over that kind of link and provide that function. Why I highlight that as the primary or that first use case of Mavlink is because only Mavlink provides that function to ArduPilot. The secondary role is basically an internal bus, whether that's between the companion computer and the autopilot, or the autopilot and other peripherals such as gimbals or rangefinders, those kind of sensors. That's even though it's still Mavlink, that's a very different implementation and use case. So where we're looking at normally a hardwired link, in ArduPilot's case at the moment, that's a UART. You generally have much higher reliability. You generally don't actually care that much if you drop messages, as long as it's not too many. So you end up with basically streaming messages and a much different kind of construct and much different kind of constraints. I'm calling that a secondary role because there are actually other ways to do that. Be that through different UART protocols, be they proprietary ones for gimbals or any other peripheral, or ROS, either via the Mavros bridge, which brings it into Mavlink, but is fundamentally a different structure, or hopefully moving forward DDS with ROS 2, which will be able to use even UART or Ethernet, but is coming into ArduPilot at a lower layer than how Mavlink's currently handled, and has access to more state if we want to give it to them. Point being that there are other ways to do what Mavlink does on board. At the moment, though, because we're trying to do both, the protocol and any changes to it have to be able to handle both. And that really comes down to implementers understanding the differences between those two use cases and not trying to do things that really shouldn't be attempted with Mavlink. So if we want something, if we want to be pushing out, high rate data, then you probably don't want to be doing that over a radio link if you can avoid it. And you probably don't want to be pushing, your Vicon stuff. You need to, but generally you're in a lab, so it doesn't matter if things go wrong too much. But just acknowledging that there are those two use cases becomes important when trying to understand why messages are defined how they are and how the microservices within Mavlink are defined how they are.
That's all good.
Right. I'm going to throw to Hamish on this.
This is your slide.
In a second. But contributing to Mavlink, this is something that throughout ArduPilot, PX4, the other implementers of Mavlink, we generally don't do very well, and it probably takes more time than I'd like trying to get people to, I guess, follow a process so that we can maintain the interoperability, standardization as far as we can within custom.xml, within common.xml, and not kind of break the hierarchy, I guess, of what goes where, when. So common.xml. Common.xml is, whilst ArduPilot maintains a fork and maintains control of its own common.xml within the ArduPilot fork, for standardization changes to common, in the first instance, we like those to go upstream into the Mavlink repo, so that the discussion about the broader utility of that message can happen with the other stakeholders. And it might be that if those changes aren't broadly accepted or aren't broadly able to be used by the other consumers of Mavlink, it might be better that we then provide the feedback to go, actually, let's create a new message in ArduPilot Mega, so that we can maintain interoperability up at the common.xml level, while still allowing ArduPilot to do what it needs to do or affect the changes it needs to make. Conversely, ArduPilot Mega is that's our dialect. They're our message definitions. We have complete control of those. Whilst we will push those just for synchronization up into the Mavlink upstream repo, they're controlled by ArduPilot. We do what we want in there effectively. Doesn't mean there's less control, less discussion, less testing. It just means we don't have to worry about other stakeholders because they're messages that only affect us. I've put custom dialects in here as well, just basically to talk about how you can use them very briefly, but more for the second dot point there, which is don't use the reserved message space in the Mavlink 1 ID range. The key thing there is if you start using those messages as a vendor and you start trying to have, and you end up, working in a fleet of aircraft or vehicles where other vendors have also used that message range, you'll get message conflicts, you open yourself up to a range of issues that step back from the intent of that interoperability of Mavlink. If you have a closed ecosystem and you don't care about interoperating with anyone else, go for your life. But on the broad, don't use them. Don't use them. There's nothing to be gained by doing it. What you should be doing, if you do want to be implementing custom messages for your own use cases, is through the Mavlink organization, put a PR into all.xml, reserve a range of IDs in the Mavlink 2 range. There's thousands of them. We're not likely to run out anytime in the next decade. And that way you can just get a range of message IDs that you can use. You don't need to tell anyone what those messages are. You just need to tell them not to use those message IDs. And that will preserve that interoperability and avoid message conflicts. At the moment, because of the way the parsing happens, no one else will be able to read those messages anyway. They'll fail, they won't have the CRC, they'll get started. But you won't have a conflict. So, at least the message will only do what it's meant to do and not have any kind of undefined behaviors. More than that though, before creating custom messages, before creating custom dialects, please look through what already exists in Mavlink. With all the dialects, there's a lot of use cases that are already being explored, already being defined. So there's a pretty good chance that what you think is a new and bespoke and innovative use case, someone else is already doing, respectfully. So have a look, see whether the messages that are in another dialect might fit your use case. And then rather than redefine a message, propose that message gets moved across into common.xml so that everyone has access to it. You'll see over the last couple of years, there's been quite a few instances of messages being lifted up out of ArduPilot Mega into common, rather than duplicating or replicating an equivalent message into common, and hence reducing that opportunity for interoperability, which is really what having that centrally managed standard is all about. The other thing, and this is something that rule scripting has made much more accessible for people, is that if your use case for a new message is relatively simple, like you're just sending down a key value pair, name value float through Lua is an incredibly simple and powerful way to get data from the ArduPilot to a consumer of it, be that the ground station or a companion computer. There's examples in the scripts directory. I think mag heading is probably a simple one where it's just sending down the heading of the vehicle over a name value float. That's all there. It's really easy to use, and it's much less painful than defining new messages for those simple use cases where it's just a key value pair you're trying to send out.
Yes, I'd just add to that. If you're developing your message for ArduPilot because you think it's too slow to go through the Mavlink process, you could well be right. But it is good as a politeness to make us aware of it. We would quite like to, if you look at, say, the RPM message that moved across recently, that was definitely improved by going through the process into common. It's not exactly the same message as it was. It does, it does more things, more eyes on stuff, more use cases addressed. Sometimes we do slow things down for no purpose. I'm not saying you must go through us, I think you'll get benefit long term. And then there, as James said, there is a good chance it will end up in multiple GCSs supported by multiple platforms.
Please.
Question of ignorance. Why can't we just send everything via a link? I appreciate there an interoperability that you're trying to achieve there, but is there another technical reason why for a closed system, for example, that we're not looking for a service, we'll just spam out a data or something?
So I guess, name value float, as I said, it just sends out that kind of key value pair. So if you're trying to send something that's a bit more sophisticated than just a single data point, then obviously it's not the best tool to use. Sending a command as a series of named value floats, I guess, is possible, but the handling on that, kind of gets a bit more complicated than using the command interface, and where you have those seven parameters kind of really defined in there.
Well, you would have to rewrite your command interface to respond with a named thingy as an act. There's efficiency of the package.
Yeah. So yeah, bandwidth efficiency and coherence.
Yes.
If you wanted to send latitude, longitude as two name value floats, well, first of all, a float can't represent a latitude better than 1 meter. 1.5 meters, depending on where you are on the Earth's surface. But your latitude and longitude are going to be arriving at different times, and they won't necessarily be consistent with each other. And so if you need to stand like a quaternion, it starts to get very, very messy. But just the bandwidth would make it, you know, the bandwidth consumption would be gone enormously. It would no longer be possible to use standard, I guess, SMA radios.
Yeah, you got a huge packet overhead there, and that's why sometimes you see these the high latency messages have absolutely all the telemetry in them. They send one message, very, very rarely.
Yeah, I mean, high latency is kind of the thing.
Yeah.
This kind of answers some of that question, I guess, a little bit. So no value float's kind of how ArduPilot sends that arbitrary data down if we choose to. And Mission Planner actually has a good way to display that within the HUD. So bottom left where you have where you can monitor all that telemetry coming in, you can actually assign one of those to a specific name value float as it's coming through. You're sending down a specific new set of data. There are some other ways in Mavlink to do similar things. So there is a named value int, which is an int32 sign. We don't use that in ArduPilot at the moment, but if we needed the additional precision, for some reason we could. Basically, the structure of that message is exactly the same as named value float, it's just an int. PX4 uses a series of messages for debug, which again are structurally similar in their intent. They tend to send vectors, I think, rather than
And this one's supported.
And also within ArduPilot, within ArduPilot Mega, we have the data 16, 32, 64, 96 messages, which are basically just sending down chunks of data. They're not within ArduPilot itself, but they are within our XML. So you can use them within Mavlink or anything like that. So I mean, Tridges use those to good effect to send video down over RFD 900 and that kind of thing. So if you want to do something that is just packing up a few bytes into the Mavlink stream, then they're there. Any questions on any of that?
I guess for big files, you could use MavFTP.
Yeah, exactly. And that's probably a better option than Data 96 for where it's suitable, and that it's a bit more coherent. But the implementation of MavFTP at the other end is obviously a bit more complex. Next. Right, that's you.
Okay. So this is a bit about pain points, really, and a lot of them are a bit about people and process. And well, I guess I'll go through them in order. Common isn't common. So I alluded to this before. Just because a message exists doesn't mean that it is implemented on a particular flight stack. Just because a command is implemented on a particular flight stack doesn't mean that all the parameters are implemented or exactly implemented as you might expect. It's quite common for one or two of them to fall off the edge. Mavlink is supposed to tell you that maybe you've misused some of the extra ones, but for efficiency reasons, it doesn't always tell you about the parameters that aren't used. There are partial implementations, you know, particularly in the early stages. I heard Randy's done the gimbal protocol. There's quite a lot to that, but there are missing bits right now. So how do you know as a user, and how do you know in what version? Similarly, yes, I've covered that. What version is supported? There are very slight difference between what ArduPilot does and PX4 does for both command protocol and for missions. And then there might be new features we want to add. And so how do you spot those things? And lots of stuff that isn't used very widely by anybody, possibly nobody. There was a lot of early on stuff that was a bit experimental. I think early on, the whole process was, we have a good idea for something, let's shove it in common. Now I'm talking very early on, way before my time. Now it's very much when we have people come along, we want at least one person or one flight stack to say, I'm going to be stakeholder, I'm going to create an implementation. And that's that's a necessity just to get rid of some of the crap that, rubbish that we've got sitting there and it's been sitting there for years. And we've tried to sort out various aspects of these, but we've had a lot of trouble finding palatable solutions to everybody. So I just wanted to look at one of these things to address now, and that is getting rid of some of the rubbish. And you may say, well, why do we need to get rid of some of the rubbish? Basically, because there's an awful lot in there that people don't discover or do discover. They don't know it's, they think it's useful. It takes quite a lot of effort to find out that it doesn't exist. It's not supported and so forth. So there's one of the very first steps. I thought if we get rid of all the rubbish, if we have a pattern if we have a better way of doing something, we all use it. Every user, and then we remove the old message that isn't supported anymore, possibly after a very long time, but at least it's gone eventually. So this is around mostly processes. At the moment, we have a WIP tag that indicates something is work in progress. We have a deprecated tag, which means superseded. Doesn't mean deprecated. It's not going anywhere. It just means that somebody else has invented a new way of doing things. And there's nothing here to tell you that you shouldn't be using the old one other than that flag. So what we want to move to is a life cycle where we have WIP, then it's stable, it lives there for a long time. Eventually it gets superseded. And as it becomes useful to people, we work to some kind of plan that, maybe in 2 years, we've got it in the flight stack. If we've managed to introduce this new thing and we've got agreement from flight stacks that's a good idea, then I think, 2 years, 2 or 3 releases is reasonable. We agreed it was a good thing. Let's actually implement it. If it wasn't good enough, we shouldn't have, for us to implement it, shouldn't have gone into common. Then superseded we'll keep, yeah, and then but deprecated really mean deprecated. And that means that we have an intent to remove. Again, doesn't have to be next year, doesn't have to be next release. And lastly, it's gone. Now, the only way I can see this working is that we actually have releases. Okay, and we give people plenty of notice what's going to happen. And those releases happen quite regularly, and they might say it's 2 years, 4 years before this is going out, but there is a plan to remove this. What I would also like to do, but there seems to be some problems with this, is have build time warnings, or if you try and build it and it's got a WIP flag and you're in a release build, it gives you a warning, some kind of build warning to stop you from including that in release. Now, there are issues with that because as Tridge said, you don't know, you don't want those messages going to just anybody because they can't do anything about it. But we do need a way of making sure that people aren't using things they shouldn't be. We don't want people taking up a deprecated message just as we're about to remove it. So we also need...
Probably worth just articulating a little bit further why we are so concerned about the work in progress messages. And the key reason there is that WIP tag basically means that message isn't stable. The definition isn't stable. Changes can happen basically without notification to the broader community as it gets implemented, as it gets tested and adjusted, to try to figure out, how to best achieve what the intent behind that message is. As soon as...
So my question is, why have that feedback, in a master plan in the first place, if you don't want people to use it?
Yeah. Right. So, and that's why we created development.xml, is to try to provide that buffer for those work in progress messages.
But that's still in the master.
Right. So the challenge is, how do you get broad testing of something without exposing it? Right. So with Mavlink, it's that's a global ecosystem of unmanned system or uncrewed systems and all the peripherals that go with that, all trying to do similar things, and we want to get them working towards a standard. So when someone comes up with a need for a new message or an adjustment to an existing message, we need a way to make that visible, but we also need a way for people that aren't involved in the development of it to understand that it's that it's not stable. It's not something they should use just yet unless they're willing to be part of that development cycle, right? So that's why we have that WIP tag. In order to reduce the risk of those WIP messages finding themselves into stable autopilot releases, we've pulled them all out of common as far as we can, and there's some exceptions that exist to this, unfortunately, into development.xml so that they are, to some extent, cocooned from the development release, from the stable releases. The challenge with that is that only works for a brand new message. If we want to change the enum to an existing message, for instance, you can't do that in development.xml. You're changing the implementation or the utility of a message to a degree, but it's already a stable message. You're just adding an additional stable use case to it. You can't do that in development.xml. It just doesn't work. Similarly, commands are like that as well. There's a few cases, and there's a few other cases, plus stuff that was already work in progress before we created development.xml that has already made its way out into stable autopilot releases, which creates a problem that is why Hamish is talking about with today, in that once someone releases a stable autopilot firmware that uses work in progress Mavlink messages, very hard for us to then change that message without breaking that flight stack. And that is not going to be accepted very well. It does create some tension for me and Hamish between the different autopilot stacks as to who gets to decide when a message is stable. And we'd really like that to at least for common.xml, to sit within the Mavlink organization. So, because we're the people that have access to all of those other use cases beyond just that one flight stack that wants to use it right now. So there is some tension there. Exactly the best way to manage that is basically just through discussion, negotiation, and making sure that everyone knows what each other's doing. So that if someone does want to firm up that message and remove the WIP tag, we can socialize that across the community and make sure that that no one has any major objections to it, or if there is a quick adjustment that can be made, that can be cycled through as best as we can. Back to you, Stephen.
Yeah, no, we just don't want we don't want you to have any nasty surprises. And so as a first step, we'd like to put in some proper process. Now, there was a statement made earlier, which was, I'm not paid for that. And that is a very damn good point. I'm not paid to just do anything either. And so that's why we need lots of lead time. And we need to have people at some sort of architectural level understanding or committing. If we're going to agree these are stable, then somebody needs to ultimately be willing to get rid of the ones that are rubbish and accept the ones that they think are important. So I'm hoping this will do this, or that we can find better ways of managing this particular problem. And we're very open to suggestions, but we've sort of tried a few alternatives over the time, and that we're just not sure how we can move forward without something like this. Yes.
I think it's really important for us as a community to understand that there is core features that were always that are there that are settled down. The only way to support development is to also those people that are pushing forwards into these new areas and using these new messages, is they understand that the pleasure of using this new message or this new functionality is they also have to take the responsibility that this is new, and they are going to have to update their systems to take into account changes or revisions and things like that. Users can't have their cake and eat it too. If they want new shit, they've got to accept that this is a development process and development of understanding. We don't know what we don't know yet, and I base this with we all divided mode stuff. I base this with as we understand the problem better, we are going to evolve that and make better. We can change all of the auto navigation to improve that dramatically. Everybody's missions are going to change, but if you want the improved functionality, you've got to take the cost of being flexible, and there's always the ability to stay with the old code. It's your decision to upgrade.
as the user, and if you want it, then it's up to you to stay up to date as well. Especially like with that new functionality labeled as new. I think that's an appreciation. People don't appreciate, you know, that there is a responsibility on them as well as us.
There is. I think it's a lot of these things are back to what is a user. Okay, so there's a whole class of users who don't care about which autopilot they're using. They are actually incapable of going into the flight stack and using this stuff. So it's more about, do we want them to be able to address certain use cases with their companion computer using us rather than an alternative? Do we want that to be easy for them, or do we want them to pick somebody else because somebody else has addressed those needs better? So even though some of this stuff is not your problem or my problem or anybody's problem, and yes, we do need stakeholders because we're sick of putting things in that just sit there forever and no one implements. That's a bigger waste of time than anything else we can do. It's not all about us. And that's fundamentally, it's not all about us. So we are trying to do a typical release cycle where we can start to highlight new things. We can start to remove old things. We can actually, one of the big things we'd like to do is have stuff in standard.xml, which is actually genuinely standard stuff that people can rely on. So that's the last point. We need a lot more testing in place to be able to do that kind of thing. So that stuff is really standard. In fact, it's a bit of a can of worms, because what does standard mean? Just because it works for plane doesn't mean it works for quadricopter. You know, I have no solutions for those problems yet.
With that standard.xml, I guess the first step we've made there is breaking out what's now minimal.
Yeah.
Which is an include into common at the moment,
Mhm.
or include into standard, which is an include into common. And that's kind of, you know, what is the minimum Mavlink implementation to exist on a Mavlink network. The next step is growing that into that standard.xml. There's some rub points, I guess, across the ecosystem as to what should be in standard, or what is the difference conceptually between standard and common. Hamish and I are trying to work through those. But I think that we will get there, so that we can get this standard.xml as being an agreed baseline implementation for an autonomous vehicle. And that will get rid of some of the confusion that exists with common.xml. As Hamish said before, just because a message exists doesn't mean it's supported. And have this standard.xml that just has supported messages in it.
Yeah.
There'll still be work to be done by implementers of Mavlink as to whether it's implemented how they think it should be. And in the case of ArduPilot, where we have, you know, 6 or 7 different vehicle type targets, how it's implemented, or if it's implemented across those different vehicle types. But at least it'll get a long way to lowering the barrier of entry for using Mavlink.
That's good.
Yeah.
What framework is there currently in terms of that can kind of helps inform these decisions? So maybe, for example, like these messages should be agnostic to solution, otherwise we're never going to be followed. And like, what about avoiding duplication in data sets of big messages? Like, what is there a framework currently that you have for making those decisions?
So the question is, you know, does Mavlink have a framework for making decisions towards standardization? Yeah. Right, so there's kind of two. One is those fortnightly development calls. More broadly, there is an RFC, and we'll get to that, I think, on the next slide or the slide after. There's there's an RFC that's linked there. But there is a request for comment, an RFC repo that sits within Mavlink. So broader proposals that are perhaps beyond just a single message, or affect something that's beyond just those definitions and actually at the kind of more protocol definition kind of level, is handled through that RFC process. So things like the component
Metadata, yeah.
was there.
The standard flight modes was the last
Standard
one.
flight modes, Gimbal V2 went through that. And so there's an I don't have a link to the actual RFC kind of list in this, but we are about to talk about one specific RFC, just to try to generate some discussion on it and move it forward.
Yeah, I would point out there is only two things. Firstly, there's no way to tell at the moment because we don't have a great process other than for submission and discussion around these things. We don't have a great process for ending them. So if you go and see any of these RFCs, you won't know what actually ended up being done by the various communities. That's not good. That's how it is. And I think also to answer your original question, there's quite a lot of, we're quite conservative about change and there's a lot of common sense in it. You know, so there's lots of questions and I think we probably made mistakes, but I don't think anybody's been thoroughly broken by anything that's gone through in recent times. No?
Just a positive comment about the gimbal messages. I'm not sure if that went to the RFC. I didn't, but
Should have.
yeah, it seemed to go through a lot of discussion between Ollie and Julie and although at first I didn't like the message that much, I've grown to appreciate them actually. So there is like one missing piece I've already discussed with you a couple days ago, but overall it's quite useful. And I'm glad I didn't have to do that myself.
Good. Yes, please feed that back sort of by an email or something, because I'm going to forget exactly what I have to do. Yeah, I like that. The statement was a support of the gimbal messages. That was quite difficult. It was an interminable process, but it solved one of the pattern problems of Mavlink is that how you instance things if you're not using component IDs to do it. And that's a pattern which comes up a lot when you're working with components. And the original solution was to allocate IDs. And at some point it changed so that we were supposed to use map type. So this is a good generic kind of approach that can be used in future to sort these kinds of problems out.
Right. RFCs.
I can introduce this one. This is a Tridge RFC. And it solves very, very cleverly a couple of problems with Mavlink or problem points in a mostly compatible way. As it says up there, it allows more than the 255 vehicles. Can't use 0 for a system ID because that's the broadcast. There's another problem that you can't, if you've got a router sitting in the middle of a system at the moment, it can't forward a message it doesn't know about. So if you've got a routing component, it has to be updated as you update your messages. Otherwise, it will just strip the message out of the stream. So this means that lots of useful things like you wouldn't have to hold all of the CRC extras which identify what a message is in your ArduPilot. Right?
You can actually route at the moment, but you can't route with any integrity checking.
Yeah.
Yes.
So
Okay.
you might route some random data that isn't actually valid.
Yeah.
So this enhancement makes routing of unknown messages more robust.
Yes. Yes, it makes it more robust, and it also does mean that you don't have to keep things updated, which is
Particularly for mesh networks.
yeah. No, I mean, I'm sure I've said how impressed I am. I would have said that this was, I looked at this problem, and I'm not very clever, but I did think this would be very hard to do compatibly, and it's pretty clever. What is the point of this statement? This is cool. I think it's the main thing. This is super cool. There's a lot of interest. It's a Tridge PR, or a Tridge RFC. So what does that mean? It means sometime in the next 6 months to a year, the full implementation will appear somewhere.
You're optimistic.
I have a question. No,
So
I did have one last point to make here. There is one comment from Ollie W, which is somewhat, difficultly worded.
It's an Ollie W.
It's an Ollie W.
I like it. He's normally pretty insightful.
Yeah.
And so I don't know if you saw it, but could you have a look? Because the RFC is supposed to be interactive, so we need to be closing the loop. Yes, sorry.
Yeah, no, I was just going to say that this addresses one of the key limitations, as Hammy said, which is the 255 system IDs. that's becoming, I guess, the common use case that people think about as to why that limit is challenging is things like the drone light show. So we're already seeing ArduPilot used with, thousands of vehicles trying to coexist. And people get around it by just having, I guess, multiple networks all up concurrently. The other use case that's growing quite quickly is fleet management, where users or fleet owners want to not have to, I guess, reassign the IDs for their individual drones, so they can just have a drone come and go from that network as they like, without worrying about conflicts. So it is quite important that we solve this problem relatively quickly. There are easier ways to solve it, I guess, at a protocol level, but not in a backwards compatible way. And that is one of the, I guess, the drivers behind this particular design is maximizing that backwards compatibility. So yeah, I'd just encourage anyone who's involved in implementing a Mavlink, particularly on large fleets, have a look at that, provide input to that, because I think the sooner we can start progressing what is loosely Mavlink 2.1, then we can start to address some of those pain points and kind of free it up to move it forward and getting that into the ecosystem. Basically, it's using IP addressing rather than just the 16-bit.
Yeah, the originally way I wrote the RFC was going to 16-bit component IDs, system IDs. But we could go to 32-bit, allowing IPv4 and extra 2 bytes. But the extra 2 bytes will only be sent if your ID is more than 255.
Yeah.
And that's the trick in this, in that you only pay the cost when you need it.
Yeah. And
it may be worth going to 32-bit for the future, where we're all on IP networks.
Yeah.
And that makes the addressing easy.
Yeah.
So what I like about this particularly is there are other ways of doing it, but it's compatible and you have that choice and it's easy. So you don't have to think, I already know Mavlink, now I don't know Mavlink. That's a damn good thing for most of us. Maybe not everybody, there'll be other approaches, but for most of us, it'll be a good thing.
I think that's all we've got. So we've got plenty of time for questions, comments, and criticisms.
Except for the last one, we're not taking those.
So open to the floor. Or YouTube, if anyone's asking questions there. Go, Brandon.
It's really simple, but all the gimbal messages are still work in progress, but everybody's using them as far as I know. They're built into gimbals that are at the door and being sold. And so the process, I've actually got an item on my to-do list to get them removed. Is that the right process? I should just go.
That is the right process. I've got an item on my internal to-do list is to put a date against all of our flagging so that there's a date, something has to be dealt with and run in CI, so I get reminded to test it again.
Yeah. It's actually a good example as to, so their WIP, and as you've been implementing, you've identified that there's gaps in the Gimbal V2 protocol. But even though it's still tagged as WIP, we can't change it because it's so widely deployed.
Yeah.
Which kind of gets back to our earlier point about how we manage, I guess, releases of Mavlink. And
I think in this case, the gap can be closed with a new message. And currently we're using the old messages for that gap.
Yeah.
So it's not terrible.
So another dimension to the slide you had about sort of management of evolving of messages and moving them from, for example, ArduPilot XML to common.xml. Another dimension to that is the fact that a particular message can evolve within itself, both in the terms that you mentioned enums, but also because of the Mavlink 2 extensions.
Yes.
And I know that in the past, one of the reasons I've sometimes resisted moving a message out of the ArduPilot XML into common is a matter of the process of who manages future edition of extensions. Because once the message is moved into common, there's some perception that then means that any project can then propose an extension to that.
Absolutely.
And there isn't a cost to those extensions. And you can get collisions of extensions because the CRC extra doesn't cover extensions.
So that's a valid point. I know everybody will have heard that over the recording. Yes, I mean, yes, you're absolutely right. That can happen. It will happen.
Yeah.
We always design for the zero, as you know, the zero value gets truncated, so it is always a choice.
Yeah,
If we couldn't do that, I guess we would use the other option, which is a bit fill where you have to set 1 to show it's enabled. So we don't ever make an addition without the possibility or the default being no change.
yeah, but it would be interesting to be able to say that if something moves from ArduPilot XML to Common XML to mark it as any extensions must be approved by ArduPilot. And is that something that's?
I don't think it can be because, so, I mean, because at the point it's moving to common, ArduPilot is no longer the only user of it.
And
that's the
point.
challenge,
That's why the resistance to moving to common.
Yeah, and so that really comes down to, I guess, an acceptance of trying to support multiple stakeholders.
Yeah.
So does that answer your question? No, that problem absolutely exists.
That's how things work, which is
Yeah.
valuable. But I thought I'd point out that was one of the reasons, because otherwise you might say, well, why don't we put it all in common? And that is, it's the management of the future evolution of messages. To me, the division of the XMLs is about the custodianship of the evolution of the messages.
So there's two parts to that, I guess. One is, you're absolutely right, and I think we kind of described that on one of those earlier slides with, I guess, the evolution and control of ArduPilot Mega very much staying within the ArduPilot organization, and Common.xml sitting up with the Mavlink organization. So, and definitely, you know, there's no intent and just wouldn't be palatable or workable to try to do that any other way. But so for things that ArduPilot absolutely must maintain control of, then they really need to stay within ArduPilot Mega.xml. What that doesn't do, though, is help interoperability and standardization.
Yeah, if we can
and
find
that's
that middle ground somehow, where, you know, we welcome all users, but somehow maintain some degree of custodianship of the evolution of the message.
Well, we do that for engagement. Well, that's
Yeah.
me standing here and, you know,
Yeah, and
representing.
that's right. And your participation has been really invaluable in that process.
So it's yeah, being engaged in that management of upstream Mavlink, I guess, is the best we can do there. In that, so between, you know, Julian, I guess, doing the bulk of the PX4 type mediation, I'm sitting, you know, representing kind of ArduPilot,
And admin.
and Hamish being the judge.
But it's not
Kind of works pretty well. It's not perfect,
Yeah,
you know, particularly because I'm not doing the core implementation of this stuff into ArduPilot.
Mm.
So there is a bit of a gap, and it kind of depends how much traction I can get with whoever it's going to affect the most within ArduPilot, and trying to get that sorted out as early as we can. But I think that the communication is reasonably good there as far as keeping people synchronized and aligned.
And we are very, very conservative.
Yeah.
You know, we don't make any changes.
Just doesn't explain what the concern is of the custodianship of the message, because I mean, we wouldn't break the previous definition that we had by adding extension. If somebody else
the problem is that there's no protection against one person adding a float, another one adding an in32. There's nothing, there's no structural CRC on that to protect and know that it'll misinterpret that in32 as a float. Plus, there is an overhead in one of the key things that tends to happen is sometimes extensions are added without thought to packing efficiency, because we are heavily reliant in Mavlink 2 on the trailing zero truncation property. And we've occasionally had extensions added after an array that causes a message to go from taking 15 bytes to taking 72 bytes on the wire, even though we're only adding 1 byte of information. And it's because of the way the packing, we utilize a particular trick in the packing mechanisms of Mavlink 2 that has some subtleties that not everyone who's extending a message understands.
I will confidently say that I have not merged, and I'm probably the only one who's merged into Mavlink in the last 2 years. No, well, occasionally, but yeah, we haven't done that.
Yeah, it hasn't been a significant issue. It's just one of those things in the back of my mind.
Yeah, we've caught that a few times, as
Yeah.
far as not badly packed extensions.
Yeah.
It is something we absolutely look for. What we
what could pop up is I guess competing extensions.
Yeah,
The biggest risk there though is not so much modified extensions or proposals to change extensions coming up into as PRs into Mavlink, but vendors that put on custom extensions. And then you end up, because you don't get the CRC check on the extensions, you end up with conflicting
Yeah.
messages.
I mean, the proper solution for us to do it longer term is to have explicit array length encoding to allow multiple packed arrays. So you have, at the moment, the only way you can do an array efficiently is have it at the end of the message.
Yeah.
But you've got 4 arrays, they can't all be lost.
Yeah.
So we could use one of the compatibility bits in the protocol header to say all arrays are encoded with a link byte, right? And if we did that, then indeed we could do that. That would mean that when we added array extensions, right, we would no longer have this packing issue, which would give us a lot more freedom in the evolution of messages.
So I would prefer even, but that's awesome because that works compatible everywhere, wherever you happen to have an array.
Yeah, it could even repack existing messages. It would, however, make the generated code more complex because it would no longer be a direct mapping to a C structure. So it can't be a straight mem copy. There has to be an explicit linearization step for each of the elements in the structure.
Yes, so I can see it's a bit hard, which is why it would be really nice if we could take some of those extensions and things that we've got already and actually have a new message and we accept that we're going to update, we're going to,
Yeah,
I don't know, because I know that's got flash costs and so forth. That's another nice way to clean things up and get your protection back on the message integrity because it's in the CRC.
yeah. The other one I've got to mention that we don't have at the moment, but we sort of work around sometimes. You mentioned a bit with the data 96 type messages. I think we should have a standardized or semi-standardized methodology for people to send structured arbitrary data, which can be larger than 256 bytes, from ground stations to applications. For example, from a ground station into a Lewis script via Mavlink.
Yeah.
But in a form where a viewer of the Mavlink can display the contents. For example, it could be JSON or Google protobufs or something like that. Some way of tunneling state data which can be unpacked and parsed. Because I think there's more and more applications I'm seeing where people are getting complex interactions of applications running with some code in the aircraft, some code in the ground station, and they want to be able to represent some state information related to trees that have been planted or tags that have been seen or that type of thing, which just doesn't fit.
So I would call that component metadata, but kind of, but it's arbitrary data in a JSON format that you move around using.
Yeah, and maybe we go for JSON, maybe some binary JSON format, maybe, I mean, there's all sorts of different formats out there, but getting one well supported by the tooling would be a huge step forward.
Yeah, so there, as Hamish said, there already is that component metadata or component microservice that's sitting there, but it's I'd argue that it's probably not.
It might not be a perfect fit,
Yes.
but the concepts are similar.
Yeah.
Anyway, let's take that one offline. It is a good discussion. If we keep on getting people who want that solved, then we need a stakeholder, and we can help provide some of the gatekeeping to make sure that changes are agreed or eliminate, or we agree that we don't need that managed.
There is an alternative that try to add around, which is to allow Mavlink messages to be defined by messages on the wire. So instead of sending over a chunk of JSON, you send over the definitions for the message at the request by the student.
Yeah, so I have a few concerns. Again, let's take that offline. I mean, that was this point, and
Hamish and I argue about this.
I think it's cool. But I reckon again, we have a system and we can be compatible by sending the definitions across this component metadata without having to change anything else.
It's also not very Mavlink-y. It's not. The problem with start doing self-describing messages is that
it makes implementation of a new message or a new application, I guess, almost trivially easy. What it doesn't do is allow interoperability. So it really depends, you know, what the intent is behind that message that you're describing, or that new message. Whether it is something that just exists in this really closed kind of implementation, or something that you actually want other people to be able to play with as well.
As you had your hand up?
Yes, I was just going to say with regard to all of the historical messages. Quality, it seems to me like a nice big order of every platform you've got access to.
Yes.
Throwing them all away and saying we're discarding all of that and ready, but everything inside put that.
Yeah, so we kind of tried
Throw them all away.
that audit of implementation is hard. I mean, no one assumes that it's easy, but it's actually harder than you might think. It is, but I mean, using ArduPilot as an example, you might think it's easy and we can just, you know, go into GCS Mavlink and look at the Mavlink headers file we've got in there and say that's ArduPilot's Mavlink implementation, but it's not. Like it actually isn't that trivial to find out even within ArduPilot all the messages we support.
And if you go back 2 versions and somebody's still running whole version of FlightStack X, but you know, and so that's back to a release process. I don't think we can do it once. I think we're going to have to do it iteratively and reliably and be able to undo things if we screw up. Yeah, I was hoping for 6 months, but actually realistically, we'll negotiate, probably end up 10 years.
And the challenge there is, you know, that versioning in Mavlink may end up being a version of common.mavlink, and it's because it's really up to ArduPilot to manage ArduPilot Mega. So there's that kind of challenge there.
Yeah, and we do want to sync with Mavlink if we can. We don't want to make it really confusing for people how the different versions all affect each other, because that is more frustrating.
Do you ever consider separating the message definition from serialization?
The question is, have we considered separating the message definitions from the serialization or the protocol itself? Well, that already exists. That's kind of what Hamish was talking about there with Mavlink versus PyMavlink, and that serialization is basically defined in PyMavlink, which is managed and released separately. So, you know, pip install PyMavlink will get you the latest PyMavlink release. And PyMavlink, in addition to the Python library and Python helpers, is that serialization, is those, you know, it is the header generation, etc. is all sitting there, because PyMavlink kind of describes more than one thing, unfortunately.
In some senses, though, I think it will be up to PyMavlink to sort out following us, because I don't think that the tail should pull the dog. So
the tail and the dog don't necessarily agree which is which. But.
Well, PyMavlink is just one output, and it's just one generator, Mavgen. So,
but it is the canonical generator.
It is a generator.
It's the canonical generator.
Mavgen is the canonical, but I would have said Mavgen C or C++ was that.
It comes out of PyMavlink.
Anyway, whatever. The point is, well, the point is that they can far more easily take a time slice of us than we can guess what they're going to do. So it makes sense, yes, sir.
The JavaScript compares itself against the single component. So that's very sort of like how to look at this.
Okay. Yeah.
Guaranteed.
Right.
I have a question on the testing of it, sort of, you know, you mentioned earlier that ArduPilot shares what's currently implemented in certain platforms. Is that someone who's manually going through and saying we support these things, or is this integrated in some test suite?
So there is a test suite. Well, there's multiple test suites.
Sorry, for what's supported, that is somebody going through it, or at least
What is supported, that is manually code inspection, basically.
You consider developing an independent set of tests that test Mavlink regardless of the platform that's implementing it?
Yes, that was what I was going to do on the fly here, and my starting point is invisible on the internet on GitHub at the moment. So it is more complicated than it looks. I think it has to happen. It won't tell us everything because whatever we do, it won't tell us everything because testing messages and commands is relatively easy, but testing in depth some of the other protocols is a lot more complicated. But it will be a lot better to be able to run a test suite and say this version of ArduPilot that X amount supports this particular message with this set of parameters, ditto with P-Explorer. And that's what I wanted to do to start off the standardization process more than the deletion process. But I mean, it is the same problem. And yes, that will happen. It's just a matter of time, that one. And somebody who feels that they have expertise, Peter Barker, and would like to write that test suite, I will be writing it in MavSDK, but the good alternative would be Mavlink, because it already there's a huge amount of test suites written in that. Yes,
I already got a whole lot about that. Yeah, the messages in the ArduPilot it doesn't actually actually implementation and just finds the ones that it says that it was. But that might be something. It hasn't been noted yet because it's discussions over whether recent Python versions are reasonable for use in ArduPilot rules.
is it a query tool? So firstly, the question was, or a statement that I already have a PR that checks for what's supported to some extent that hasn't been merged. And my response or question is it just sending messages or commands and seeing if it gets a response, or is it a threat or?
It doesn't check what has been it just parses the ArduPilot code base and finds that that's like where the finds messages go like that is messages defined in ArduPilot.
Okay. Just for my interest, does it also break down by vehicle and?
Yeah.
That's cool. Yes, that would be useful. It doesn't have to live in ArduPilot to be of interest to me. So if I'll chase it.
Yeah.
We have some generated case.
Yeah.
What repo is that PR against?
It's again the ArduPilot repo. Just going into the build.
Yeah.
The only thing holding that back is
Yeah, I think our thinking on that has evolved relatively recently as well.
Yeah, we got
Respond.
right.
Yeah, so, I'm out of time.
316. So I'll be floating around if anyone has questions.
Yeah, I'm here all day. So we're out of time. Thanks very much. Thank you very much. I was going to say done with Mavlink, but another plug for the panel discussion at the end. So if you're on YouTube, you've got questions, put them in the YouTube chat. If you're in the room, there's a whiteboard over there. Just so we can start coordinating and structuring that panel discussion. Thanks.
So thanks for all your efforts on the Mavlink standardization. It's really is appreciated. So this is the final presentation before we do the future development discussion, panel discussion. And Ryan Beale is presenting on rotor development. Over to you, Ryan.
Thanks for being here, guys. I've had a blast listening to all you guys talk. Learned a lot, and I'll try and close this out with a pretty short brief here. So, brief overview of what I tried to accomplish. So the goal was to create a high fidelity tilt rotor model specifically for ArduPilot CITL. So the steps that I took were 3D Studio Max modeling, and then of course inputting the real flight physics. And then, testing out the model in CITL itself, kind of evaluating some kinematic equations to make them better. And then what is required from Lua management perspective, and then sort of what's needed going forward from an ArduPilot integration perspective. So you can see the vehicle that I chose is the Bell V280. So one of those is a real flight model and one of those is not. So I think it turned out pretty well. I was pretty impressed with the whole process. It was a kind of a fun project. So in 3D Studio Max, if you're not familiar, it's sort of a bear if you're not in that world every day. The important thing to get it into real flight is object naming and hierarchy. And you can kind of see here what those look like. The hierarchy is sort of important specifically for how the physics presents to you in real flight, so you can break apart as a wing or whatever. Some of the name matters, like the prefix, but the actual name on the end there doesn't necessarily matter as long as you know what the parts are. Pivot orientation is sort of painful. You really have to make sure that your pivots are aligned correctly, and you go back and forth on that until you import it correctly, but you figure it out eventually. One question that most people commonly have when doing this work is, can you use an open source tool like Blender? I quickly looked into this, and as far as I can tell, the answer is no. And the reason why is because Blender exports the FBX format in a binary format instead of ASCII, and real flight requires it to be in ASCII. I'm not an expert. I wouldn't claim to be an expert in that world, but that's what I found.
Done with Blender, just with some extra steps.
Okay.
Yes.
Okay. Okay.
Yeah, the plugin maintainer is actually in our simulation channel on Discord.
Cool. So one trick that I did sort of figure out that I think a lot of people haven't really pushed the edge on is prop modeling. And the way to do that is basically, remove the prop and model it as a separate entity, and then bring it in as a custom prop. And where the prop sits, you essentially define the prop as a plane, and whatever's in front of that plane in the origin space will then rotate. And so it looks like it's spinning, and you attach the prop in post. The TGA files. So in my development environment, typically I have real flight on another machine. And it took me a while to figure out why it wasn't importing correctly. And that's because the visual texture file, the TGA file, when it gets generated by 3D Studio Max, it's hard linked on the folder structure that you have on the computer that you're doing the 3D Studio Max in. So if you're bringing that file across to another machine, for example, you can simply rename the directory and do it manually in like a text editor or whatever. So if you get this far, congrats, because it's extremely painful, as most people well know. But the good news is you're basically done. So, what takes like 2 or 3 days to get here, you end up spending about 20 minutes, and then you have an airplane flying, which is really nice. One of the really nice features of real flight is in fact that, getting the physics pretty close really quickly is super easy to do. The interesting things that I found with respect to tilt rotor in real flight is because it is so symmetric, the hierarchy that you end up building is very, very simple. There's very few things that you have to put in. So a symmetric wing, in this case, it's a V-tail, so a symmetric tail, and then the tilt rotor, the tilt mechanism on the end, and then attaching the motor. And it's literally one element that's just duplicated to the other side. It's done really well. In this case, I ended up going with I tried both fixed pitch propeller as well as constant speed, differential collective, and that's where I got into the modeling piece of creating a custom prop rotor, and then applying Real Flight's collective pitch. And that turned out really well. You can see it in the animation as well. It works just like you would expect it to properly animate, which is nice. The collective pitch I ended up ranging out was -5 to 45 degrees. And then the constant speed part of it is just controlled by Real Flight's governor. So if there's a drop down that you can pick as an ESC governor for like a helicopter, let's say. And so that's what I chose. Flaps and ailerons. The flaps are a big part of this kind of vehicle because you want to reduce the surface area, the planform area, the wing as much as you can when the prop rotors are vertical. And so in the model, I have quite a bit of drop. I think it's like 65 to 80 degrees or so. Yeah. And then in this configuration, it's a V-tail and rotor and elevator combination, obviously. So this is what it looks like in Real Flight. I'll quickly show a video if it plays.
It's not collective on nitritis. Some is slide, there's no slide.
That's correct. Yeah, and I'll talk about the dynamics after the video stops. Yeah. Yeah. Okay. So some of the findings I found were the kinematics that this type of vehicle require, as you would expect, a handful of mixers. As you tilt the tilt rotors forward, what was roll turns into yaw, and what was yaw turns into roll. Some of that is in the tilt rotor code in ArduPilot as it stands now, but not all of it, and it's not all complete. And so I basically configured it to the max extent that I possibly could, and then added in some of my own, which I'll talk about. But ultimately, this is the simplification that I came to, and this is, bear in mind, this is very simple, mostly for conversation sake. But you can see I've broken it down into the moments of L, M, and N, specifically roll and yaw, so L and N, and then the acceleration forces in the x-axis, so that would be out the nose, and the z-axis, which would be vertical. Those are the primary dynamics for the non-linearization that the tilt mechanism applies to the vehicle. And so I loosely put those down just to show the generic mixing there. And then if you invert those equations, let me back up one step. So alpha in this case is the tilt angle from 90 degrees down to 0. And so the ultimate goal is to figure out, how much thrust you need to generate and how far you need to tilt those motors. And so in Peter's previous talk about motor mixing, a lot of the nonlinearity that he was trying to capture was at the extremes where the actuators or motors in this case are saturating. The upfront part is fairly linear in the sense that the thrust vector doesn't change. And so there's not much that you have to really linearize per se, other than a basic motor matrix. However, for a vehicle like this, before you even hit the actuator saturation, all of the controls are nonlinear. And so adding this step in significantly reduces, issues that the PID then has to compensate for. So I broke it down, into the thrust and the tilt explicitly based on those 4 commands. So your lateral acceleration, your vertical acceleration, your yaw command, and your roll command. They're very basic here, and I don't really highlight in these specific equations, things like turning off roll completely when they're fully down. So in this case, to generate roll, you would tilt differentially the tilts. Most likely I won't do that, but it is technically represented in the math there. So you would just have if statements or just drop it to 0 heuristically in the equations that you draw up. But that's the basic kinematics of the vehicle, at least. For Lua management, this was just a quick and easy. It was relatively simple to sort of manage the bring up of the vehicle. So because it is a constant speed collective pitch, I needed something to manage bringing up the governors. And so, simple, easy fix to do that in Lua, just check for arming and throttle position and then bring up the governors. Some things that I didn't necessarily anticipate was speed scheduling the collective. As you can imagine, having that vast of a collective range, you can quickly create a massive parachute, depending upon your speed. And so making sure that you schedule that based on your speed, is important. Do the same thing with RPM management. You know, when you're flying as a fixed wing, you don't need all of that RPM, so you can back it off. Motor spool up management, like I said, just managing the governors. So really the goal of this whole talk and investigation was to figure out the corner cases for ArduPilot, like where it's strong and where it's weak. And I found, I think, both of those. So the vehicle type that I've illustrated isn't technically supported. It's a combination of a bunch of different vehicles. So it's a quad plane, tail sitter, bicopter. And if you go to configure that, you'll quickly realize that you can't explicitly configure that directly. You've got to do a couple hoop jumping to get that done. But it does come up and it does fly. I'm suggesting, I think at this point, to create a new airframe class specifically to capture some of that mixing that I recommended earlier, because it's not as well defined as it needs to be. Some of the mixing is there for like a quad plane with where the two motors tilt forward, for example. There is some thrust compensation or tilt compensation that de-weights roll as they tilt forward and things like that, but it's not quite complete enough to have a smooth transition on this vehicle specifically. One thing that I did find that wasn't represented anywhere except for trad heli was roll to yaw coupling. So I'll back up a couple slides here. When, you know, in this specific case, it's differential collective to produce a rolling moment. And so as you can expect, like, you know, one collective goes down and one collective goes up. And what that does is it produces an asymmetric yaw moment. And so there's those two modes are coupled. And so typically what you can do is you measure your roll force and then you feed that forward to correct for it. So I just created a quick little patch. It's pretty straightforward. You can see what it looks like there. But that same effect would apply in, say, like a tricopter, like a pure tricopter. So it'd be nice to have that sort of universally applied elsewhere in the control laws. It doesn't necessarily have to be this vehicle specific. There could be other uses or other vehicle types that would take that kind of a coupling. Yeah.
Something that we could think about doing is genericizing some of this stuff by making actuator-based classes within motors. So instead of having, you know, 80 motors carrying 80 motors doing carry, we can try and have another subclass of actuator with client, and then that make it a little bit cleaner to share that throughout the vehicles.
Yeah, so the question was essentially genericizing the current motor mixes to capture some of these dynamics heuristically, sort of like in the actuator itself. I guess the way I would reply to that and like push the question back onto the audience is I sort of see that as what Leonard and Bill are going to be doing in the next 12 to 24 months. As sort of like reconfiguring the whole flight law structure such that it can include more of these nonlinearities that you can specify. If you've ever used, I can't remember the name of the flight code now, but it was on a KK2 board and it was specifically made for VTOLs. They had something similar to that where you could basically define this rotation matrix in a big matrix of all the possible gains and rotations that you could ever want. And it can get pretty messy because, you know, you're basically doing all things for all people. But the good news is you can do all things. So it's complicated to set up and it's complicated to get right. But it does add a lot more flexibility. So I think the interim step for me is probably going to be to just create my own vehicle class. I would like to sit down with, you know, Peter and Tridge maybe and see if I'm missing something obvious where I could just, you know, add a couple lines of code to clean off the transitions. But I think ultimately, like where the whole ArduPilot project needs to go and, you know, in the future to be more robust to these kinds of vehicle types is exactly that. It's like what Leonard already, you know, sort of presented.
Yeah, the extension to that too, that I did mention in that law is the potential to define some of those subclasses as Lewis groups that are used and actually allow those books to be sent off to a Lewis group, something like that. Again, this is where that feedback from everybody that understands the programming side of things to a much deeper level could help provide that flexibility.
Yeah. Yeah, that's right. And the primary goal of building this model was to have a model that we could test against, that we could test these nonlinearities in. One question I've got from a friend was like, well, why not just build the V22 or use the V22 model that's in real flight? I could have done that and just stripped out the physics and cleaned up the physics to be more, more accurate. But honestly, I kind of wanted the challenge of a contemporary new vehicle that just hit the market kind of thing. The V280 is the new replacement for the Blackhawk. And so I figured, getting that sort of a structure scaled down like 20% scaled would sort of give us a pretty good starting point.
Just a quick question, when I use root for this sort of thing, I'm back from just doing code just for the search. 3 years ago, that version, it didn't capture the reaction forward. The fact that if you had a moving motor, that it would be sort of quickly rotate, it wouldn't capture the fact that there's a reaction forward on the aircraft. And that gave positive departure from real tuning results.
Yeah, I think that's probably right. I think there's a decent reaction torque in the opposite rotation of the propeller spinning. So as you accelerate the prop or decelerate the prop.
Just when you rotate those cells.
That's right. I don't think that's represented. Yeah. Yeah. That's right. That's right. I think, the sort of the observations that I've made is that it's relatively good from a fidelity perspective. There are a handful of things that are poor. So a good example of something that it does really well, in my opinion, is showing the bandwidth case for a fixed pitch propeller versus collective pitch. So trying to get a vehicle like this to fly with fixed pitch, you lose your bandwidth on your roll control quite rapidly. And I'm sure a lot of you guys are, familiar with Tom Stanton's V22 work that he's doing. And he's doing exactly that. He's doing it with a fixed pitch propeller. You can get it to work. And I did get it to work in sim, but your control bandwidth is really low. And so I already knew I was going to go collect a pitch anyway. So I went ahead and jumped to that step. And it's amazing how much bandwidth you recover.
So what version of Root Flight do you use?
9.5.
So I was using 9.
Okay.
The reaction torque dynamics by how they sound like.
Yeah, I don't think so. I could validate it and check. The other thing,
Is there momentum characteristics of the propellers?
yes.
So they've got the information they need there to do it.
Yes, that's right. I think probably the most egregious thing that this model doesn't cover, in my opinion, is power absorption from the propellers, the prop rotors. So the power model for the standard fixed pitch propeller that they produce, I think, is relatively close. It seems to model something like Mark Drella's motor model and propeller model. So I think those numbers, if you put those numbers in, you'll get relatively close numbers on your power. But whenever you switch to collective pitch, I think they quite literally assume flat plane with no twist. It's speculation, but I think that's right, because the power numbers that I'm seeing are representative of something like that. And so it's sort of juxtaposing that with what you see with reasonable power numbers from a fixed pitch propeller versus, switching to collective.
Certainly wouldn't be capturing flight stall in your settings like almost available.
In some case, I think there's actually decent modeling there, but at least what I've seen on the fixed pitch propeller side, they do have CL curves and profiles that you can put in. I put them in for this prop rotor specifically, but the power numbers seemingly at this point aren't right. You can fudge it down, so you can set an artificial gain to lower your power numbers to get closer to what you want. But I sort of stopped there. I haven't really. I was more concerned about the GNC side and less the performance side. I'm not necessarily trying to, use the performance numbers from real flight to approximate a vehicle, but I was more specifically just trying to create a robust enough model that ArduPilot could use to really suss out this type of vehicle type for testing.
Did you think the prop wash onto the wing that affected that loss of efficiency, or the force of that causes it? Would you assess that that seemed to be about right?
So the question was, the efficiency loss due to prop wash impinging on the flight surfaces, like the wings, is that modeled correctly? I don't think so. But I haven't really, checked it again, because the collective pitch power numbers are so far off. Primarily, I think in hover, they're pretty close, but in forward flight, they're not. So
you can ask on the forum. There's the key person in real flight is Jeremy Stevens, and I've had a private chat with him for some years now. You can also ask him on the forums questions like that. Doesn't always answer, but it is the primary weakness of real flight. It's a great system for getting quite a complex vehicle going reasonably, very quickly, and making large scale adjustments very quickly. Make this one tilt, make that one collective pitch, make this one whatever. Very good for that. But you hit a wall where you then can't, if you want to add a more detailed physics model into a particular piece, you can't.
that's right.
It doesn't have the hooks for replacing in a new physics model, a more detailed one to capture the dynamics that you really care about.
That's right.
And that's where gazebo, it is potentially a lot better, but it's a higher hurdle to get that initial big going.
Yep, that's right. Yeah, I think, the simulation that I've been around, at least from academically, it's almost certainly plagued by units and things. So it's garbage in, garbage out, and you've got to be really, really careful with believing your own sim that you created.
Yeah.
And so I think, to your exact point, real flight is a great starting point, because you can size up an arbitrary vehicle really quickly and get some basic performance to prove out, some corner cases and control laws that aren't sufficient yet or whatever. And I think that's exactly what this did.
And fixed wing tuning is surprisingly good. I found that as long as you pay attention to the mass distribution, the deflections, the size of the surfaces, then I can usually give somebody a tune in real flight, and the auto tune ArduPilot produces something within around 20%. And so it's quite reliable, the tune that I give them. But that's for larger quad planes. As you go to smaller vehicles, less good.
That's right.
But for 20, 30 kilo quad planes, when I'm giving people tunes, it's just blowing.
None of that's dynamics too.
Exactly.
We don't have much visibility as to what's happening.
And usually I do a conservative thing where I take the auto tune results in real flight, and then I back off the gains somewhat, just to get them flying.
There's a surprising amount, servo time constants and stuff. There's a surprising amount of modeling in there that you can do. Slew rates on things, and it is quite impressive. I guess one of the last things that, from feedback to Tridge is I did use QuickTune to tune it in in loiter mode, and it worked great. It got it tuned up, quite rapidly. Now, that being said, that was in the collective pitch mode. In the fixed pitch propeller mode, I had to tune it manually because it was just too much. But yeah, from the pure loiter perspective, the loiter controller on this vehicle works really well. The bicopter motor mixer works really well. As long as you're not transitioning, it's fine. And even still, the transition still works. There's a couple of things that I worked with Peter on, that it basically just goes full throttle on transition. So the motors are straightforward, and you cue the transition, it goes full throttle. And so you don't have time to tilt them over, and so it just climbs like crazy. And so from the perspective of trying to hold velocity, the current configuration of quad plane, bicopter, tilt rotor, tail sitter, it doesn't capture that, but yeah.
Much more cautious about giving people VTOL tuning out of real flight. You can end up with very bad results because it doesn't capture any of the vibration stuff, any of the flex of the frame. And so you very often end up with gains that are unrealistically high in real flight. They put it on a real vehicle with some twist and vibration and things, and their D term will be oscillating like crazy on the real vehicle, which it wouldn't in real flight. Fixed wing is a much better for actual tuning. As far as pilot training, it's great for VTOL, but the tune, not so much.
Yeah, and I like using it for just generic physics. So what I mean by that is the transition, setting how I know I'm going to be coming in at say 22 meters per second for my trim airspeed, then I can back out how far I need to start my transition waypoint and stuff like that. So from that perspective, I think is, your deceleration profile for your back transition and all that, it's really good to sanity check those numbers in something like this, because all those numbers are going to be relatively close. Assuming your calculation of stall and all that's correct for your vehicle. But yeah, that's proved to be the most useful for me. The last vehicle I did this on was around, I think 30 to 40 pounds, depending upon the configuration. And I didn't use it for gains at all, but I used it for all of my waypoint planning to set up my transition kinematics, and all of that worked right out of the box. It was spot on. It took me a couple of days to dial it in real flight, but all of those numbers transitioned over to the actual vehicle flawlessly. Well, that's all I have. If nobody has any more questions.
Okay, I got one.
Sure.
Right at the beginning, you were using a 3D modeling. I was showing, I thought that in real flight, you could already design your own airframes and stuff. I've actually never done it, but I was wondering why, would it just make it look more accurate, or like why the extra tool?
Gotcha. So, I mean, as far as I've only done this like 3 or 4 times now. The typical approach is to take something like SolidWorks or Fusion 360, and then export that as a step file or STL. I can't remember which now. And then bring that into 3CO Max or Blender. That gives you the generic shapes, which ultimately ends up being a bunch of 3-dimensional points in a big ASCII file for all of the triangles that shape represents. Oftentimes, you'll find that you'll have way too many triangles because your shape is too articulate, and you can decimate down and that kind of thing. Specifically in real flight, as far as I know, there's no way to draw an airplane in real flight. They expect you to import some shape, and then from there you can really easily outline the physics scaffolding that you saw right here. So all of the yellow lines represents the physics scaffolding. There's even a button where you can click on to essentially take the visual image that you imported, and it'll wrap the physics scaffolding for you. So if all your dimensionality and scale is correct, it'll wrap that generic shape as best as it can. Sometimes it gets it wrong, but oftentimes it gets it fairly close. So it is pretty easy to take, somebody else's model and import it. There's a couple caveats to that, but you don't have to do the design work yourself either. Oftentimes getting the texture mapping to line up with the solid shape is very difficult. But yeah, that's how you do it.
On the Blender plugin, just for the record, Bob Long who's a recent dev team member, just joined the ArduPilot dev team just recently. He is the author of the plugin for Blender that allows you to use a pure Blender without buying 3ds Max. You can use Blender to go from word go. And he's in our simulation channel as a recent addition to our dev team.
Awesome. Yeah, that should help a lot of people bring stuff in.
Yeah, the other thing probably worth mentioning, if you just want to try a new geometry, you don't actually have to have all your model, right? And this is probably where Randy.
That's right.
Is going. You just grab your plane, your little twin motor, whatever, and then you make you make them articulate, and you move their position, and you can sort of test it. Your model doesn't move, right? But the physics is there.
That's right. Yeah, a great example of that that I did recently for a partner was the E-Flight Vergence, or the Convergence, or the tricopter tilt rotor. Their airplane's very similar to that, almost identical, but with different dimensions. And due to their construction, they couldn't get the CG far enough back onto the VTOL motors, and they're wanting to prove out, like, is this sufficient? And so I just took that model and moved all the physics scaffolding around, and doesn't even line up with the vehicle at all. But it's, representative of their airplane. And so when you see it, it looks like the E-Flight airplane, but it's flying their physics. So that's a great example, and it's super useful if you don't care about the, what it looks like.
Don't care about windows.
That's right. And another great example of that is the V-22. If you look at the V-22 physics, it's basically a quadcopter underneath, and then they just tilt the quadcopter. they totally cheat. Yeah. Another cheating example I've seen in real flight is the Prandtl wing. I won't go into the physics of that, but it's a tailless flying wing. I found a real flight model that this 3D printed company makes of their model that they sell. And I was like, oh, this is gonna be kind of neat to see if real flight can handle, you know, a Prandtl distribution without a vertical tail. And I pulled up the real flight physics and they cheated and used tails.
Yeah.
So yeah,
You can't see them, but
it's there. That's right. Well, awesome, guys. Thanks for letting me talk.
All right, so thank you very much, Ryan. So the final session we have is like a dev team discussion where we really want interaction between the audience, dev team, what's going to be happening in the future over the next year, couple of years. The idea is to get a few of the dev team up the front. And now we've got a few minutes where we've got afternoon tea waiting over there patiently. So what I suggest we do is that people grab a bite to eat, and we might then migrate some of the dev team members up to the front. We'll rearrange the tables a little bit, and then hopefully get some sort of useful session going. Yeah. We need this. The microphone needs to be over here. Yeah.
I'm gonna put this here.
I'm actually gonna go.
Sorry, you're heading off. Okay. So good to see you. Thank you very much. That might say something about you, you know.
However you need to handle my works.
I don't like to sit down.
Yeah. Well, everybody would sit down.
Need a few chairs, so. Some chairs. And Pete's definitely, Pete's Hall, we'll get you up here. And Peter Barker, Sid, I think. John, would like to come up, Rishab. So we'll have a few people. Yeah, that'd be great. Thanks, John. I don't know. Depends how many, who was shy and who's less shy.
Thank you. You're welcome.
Yeah, that's a good idea.
Now, maybe you're not.
Alternatively, I could plug the mic in here and do it here, but
Yeah, let's probably just scoot the tables down a bit. Right at the end there.
all right, everyone. So if we could possibly take seats. Now, of course, this being right at the end of the conference, we've already got some people who've had to take flights and head off. So that's understandable. And so it looks like I need to squish across a little bit to fit. Yep. Yes, in here. That's Peter there. Yep. So Randy, you gonna grab a chair behind? Well, why don't you can hover. You can stand behind.
Yeah, okay.
That's just your mate.
So, in your lap.
Yeah, just lay down. Got all this room right here.
Okay, yep, that's recording.
It's good for your
Okay.
neck. Good for your neck.
So this is really sort of, this is not all the dev team. Half the audience is dev team. This is a dev conference, right? So really, if we wanted to get all the people who are involved in the development of ArduPilot, it'd be the entire audience, or almost the entire audience. But really, this is just a bouncing ideas type session and thinking about what sort of things. I'd particularly like some of the bigger ideas that are going to make a big difference for our user community. And so Randy asked for some suggestions in the chat a little while ago. I put a couple up there, so I might actually just share my screen here and just be aware that this is going to be sharing the Conf 2023 chat, which has been a private chat up to this stage, but I think it's reasonable to now make that more public. So now, there we are. So can people see that? And so there are a couple of little ideas for topics that, should we just do them in the order that they came in on there? Any particular reason, Randy, you want to do? All right. So there's one here that Randy and I were discussing this morning, and we were trying to think about this debate about putting code in Lua versus C++. And there is one of the reasons we sometimes decide to put it in C++ is because the barrier to entry for installation is higher for Lua. You have to download the Lua script, you have to set it to scripting, you have to enable scripting, you have to get the right heap size set up, etc., which are steps which for an experienced user is quite manageable, but for a feature that you're aiming to be very available to a wide number of users is a step too far for some cases. And so we had an idea where, inspired by the way we do terrain data management. So by default, we have terrain enable, and the ArduPilot automatically downloads terrain data tiles, asks the ground station, go and get some terrain data. The ground station goes off to a server, our terrain server, downloads that. And without the user having to worry at all, the only thing the user has to worry about is, oh, pre-arm, we don't have all our terrain data yet, right? So we could do that with Lua scripts. We could actually, for example, the DJI gimbal driver is a good example. So at the moment, the way you do that is you set the gimbal type to scripting, and then you install the right Lua script, reboot, etc. And then within that Lua script, you set a parameter to say the type of gimbal, etc., etc. Okay. If instead in the C++, we actually had an enum for DJI gimbal, but the implementation of that in the C++ is a line in a table that says this ID requires this script, and then that is just like a 3-line implementation in the C++, then the ArduPilot's job then, when you select that enum, is to check, do we have that script? Is it of the right version? If not, ask the ground station, go and get me that script and supply it. The ArduPilot code then has to install it and enable it and start scripting and then say, all good, and we're done. So in other words, we would automate the management of these applets and drivers so that the pain of that installation process is vastly reduced. So that was one idea that we had.
We could essentially add these scripts into the APJ, during the install process, they could be automatically loaded onto the SD card.
They could be, yes, because if we'd assume SD card space is available, it could be preloaded onto the SD card and then a bit like preloading terrain, but that would be quite practical. I did look at the possibility of including them in ROM-FS, and I looked, for example, at the DJI gimbal one. It's 33 kilobytes. Now, our ROM-FS is compressed with gzip-9 automatically. And so that comes down to, for your particular gimbal driver, Randy, which I'm using as the victim for this idea, it comes down to about 9K. And thinking 9K hasn't really saved us much in the way of flash space versus just implementing it in C++. So I didn't think building it in ROM-FS would work, but in the APJ is much more practical as an additional segment in the APJ that then gets with it. The trick is that then the bootloader that interprets that APJ potentially would have to understand the file system, which comes across to Peter's file system.
Or it could be a later step. Like
it could be that the ground station understands the parsing of that APJ and downloads. But I think it would work a bit like the terrain data, though. I think it would work quite well, particularly with version management. Yeah. Where it would be able to check for new versions, just like Mission Planner currently tells you there is a new version of ArduPilot available. Would you like to upgrade? It would similarly, if you do releases of these scripts, and we have an API, the ground station can ask what the versions of the scripts installed are. If it then informs the user there is a new version of the DJI gimbal driver available, would you like to update?
Or even able to, I don't know, downgrade for some
or go back to an older version. We would need a management page for your scripts, but as much as possible, automate that process so that the enabling of a driver that is in C++ and the enabling of it in Lua becomes a very similar experience. In fact, the same experience for the end user.
Does this get us into an issue with backwards compatibility? I mean, software version.
Yeah.
I'm just thinking about backwards compatibility in terms of, software is at this version. You've got drivers that update. It means the process that we use with our testing. And now we've got to check these Lua scripts against how many versions.
So Josh Henderson added something into some of the scripts that he created, some of the driver scripts, like the EFI drivers that he worked on, where it had pieces in the Lua to check the ArduPilot version to say what version was required. If we standardize that format, then when the request comes to the ground station, it could say, I need something that's compatible with this version. And it may not give you the latest DJI gimbal driver if it's not compatible, but it might give you the latest one that is marked as being tested and compatible with the version you're running.
That's right. So in other words, it's the versions that have been tested.
Yes. So you would have to mark in the script that this one is compatible with ArduPilot 3.4.1 plus. And
could be just a little description that you have to put in beside every script. So I'm just thinking here that we need to keep it simple. You could just put that in the description just about display to the user. So when they're picking the version of the script that they're interested in, they can read the script and say you must have 4.6 installed.
Yeah, some users aren't really aware what ArduPilot version they're running, particularly if they're running a vendor branch, which might show up as, foo pilot, whatever, rather than ArduPilot, and they're not necessarily sure what base that was from. Yeah. So the suggestion from Matt there was to automate that with metadata, either in comment form or in Lua form that, you know, tries to automate that versioning. And I think that would be very worthwhile. Yeah.
And in our metadata, we would also need, oh, this script uses X amount of memory. And then we need some fancy error, right? If you try and load 3 or 4 scripts for different things, the total of memory maybe goes over what's available, and we have to say, oh, you've got
not enough memory. Yeah, that's right. You have to have the heap size that is required.
So this seems like more of a having like metadata for each of the Lua scripts that you have on board. At least the applets, pretty much like this is how much the requirement is. This is the version it supports, and
so it's an idea. I think we don't flesh it out fully at the moment, but I think aiming to make our Lua drivers very, very easy to install is something that's worth discussing further.
For sure.
Just one last comment, maybe Michael wants to say whether or not you could actually implement such a thing.
Hello. I actually think it's a good idea, and I do think the online check conversion is a good idea. The ability to update in place and just the general way to install. I do agree with 100% with all the metadata though. As a user loads 3 or 4 scripts, the stack size is going to increase. There are many caveats that I can see there, but as long as we think about that and hash that out further into the future, I think it'll be fun.
Yeah, we could prototype it in Mavproxy to start with, like we did with the terrain data, and then see how it works. And then, that also gives us the ability to then test it in CI. Yeah.
I just want to make one comment. We need to have some form of agreed architecture or like process in place if we're going to do this, so that we agree what features go into Lua and what don't, because otherwise it's going to become a mess. So like we need to make sure, because for example, we could say, oh, something has to be like, if something is flight critical, it goes in C. If it's not, it goes in Lua. Otherwise, we're going to have this mishmash of features. Some stuff is Lua, and some stuff.
We do have some flight critical drivers now in Lua, and it's sort of based on number of users, complexity, ability to evolve. There's a whole lot of factors that go into that decision. Even the familiarity of the developer with the tooling. And some of our developers are more comfortable with the idea of creating robust Lua drivers than others. And so I don't think they can really come up with a really firm rule on it.
I mean, what it will give us is we've got this server, right, that's serving all the scripts. We can tell how many people are using script X or script Y. And maybe we say, oh, 10,000 people have downloaded this script this month. We've already reserved the gimbal driver enum, right? Perhaps we just move it into C++.
Perhaps not if we're incorporating the APJ, because it's the GCS that knows what's going on.
All right, so that's probably enough on that one. The second topic we had was, this came out of a discussion with John Challenger earlier, and also the state estimators with Rob Mahoney and Peter Van Gore and Sean Gee. Creating a data corpus for regression testing of state estimators. I'd love to see a repository somewhere with replay logs, preferably replay capable logs, along with some metadata about, a photo of the vehicle would be lovely, and information. So I've actually got a bunch of these logs already. Philip, I suspect you've got a bunch.
Yeah, I was just going to say, I know some people don't realise, but we've got drone share back up and running. We would love people to start putting up logs that they're able to share on that. You can do live sharing from your healing, you can do all sorts of stuff. But yes, ask for what you should have set up before you can do logs.
So just to go over that, log underscore replay equals 1, and log underscore disarmed. I use option 2, which people may not be aware of, which is that when you hooked up by the USB and you make the RAM changes and things like that, it doesn't log. But when you connect the battery without the USB, you'll apply it does log. So That's just something that might be useful for some people, to be less burdensome. And then we're kind of, in some respects, we're more interested in those logs where something that goes wrong. Like, for example, one of Michelle's quadcopter flights with a racing quad with it clips the IMU or it drops off the GPS, for example, would be fabulous. And I know we've got other people in this room who have setups that are non-standard, because they're the ones, we get those corner cases, and they're the ones, you know, that tend to push our estimators the hardest.
Although having logs where it went right is also useful, particularly, say, for example, the GSF one, we can in replay turn off the compass in the replay and see how it would have performed without a compass.
So we have some specific, I'm thinking about some specific issues that have come up, which we've put in pull request to fix to improve performance.
We should have captured those better for regression.
To those logs, because then it avoids us falling into the trap where we make an unintended change later on, and then we undo the fix.
We have had an attempt at this before. I've had sort of collections of logs, but I just think that creating a bit more infrastructure around that would be very worthwhile. So probably enough. Oh, the log disarmed equals 2. I want to do a log disarmed 3, where what it would do is it would be logging all the time, but it logs to a temporary file, and when you arm, that gets renamed to your log file. So if you never arm, that file gets overwritten.
Yeah, we actually do have a PR in place which gives us that functionality. This hasn't been merged.
There, and that again would be a similar sort of idea, but even quite often you're sitting on, on battery for a long period of time on the ground, and you reboot, you just might as well wipe out that log if you never armed.
Question for the floor.
Yep.
It would be sweet to have the acro flight of the 2 vehicles on the log server, just for users to go play with.
For your aerobatic flight.
Those ones, oh sure, yes, the aerobatic ones, the fixed wing aerobatic stuff. Oh sure, those logs are. I actually put up most of my logs on uav.trigil.net, and this initial corpus will probably come a fair bit of it from scraping stuff, but I haven't always had replay on, partly because I haven't. This log disarmed equals 3 is what I want to make it possible to have replay on and log disarmed essentially all the time on all my flights,
like that,
without ending up with a SD card getting full. And I think it will make if you reboot just before you fly, it'll work really well.
I have a plan to optimize the prediction set of the where it will run it irregularly. So essentially, it will only do a prediction immediately prior to using an observation, and logging that would significantly compress log replay.
I might comment that the source data is where most of the size of our logs comes from at the data abstraction layer, and I don't think that will change that size. Okay, it will reduce the size of the state estimates that are baked in the log.
Right.
Not the source data. And then we've also got the output observer, which runs at the full loop rate. So the most important thing is that source data.
Right.
If they're down.
All right. So the next topic I've got listed here is from Josh Henderson. Hello, Josh, if you're watching. So she's raised the point, should there be some discussion about the usage of foundation funds and status? And there have been various emails about other support folks. James or I, shall we give a bit of a how it works type thing? Are people interested in knowing, how we dispose of your money with trips to the Bahamas and things? Sure, James.
The Bahamas are a long way from here. We're not in Kansas.
So probably stand up there or behind.
No, I'll sneak up behind you guys. No.
That might will work.
Yeah, it will. So Tom and I are 2/3 of the funding committee. The third wise monkey is
Andy Piper.
Andy Piper, yeah, who's probably asleep at the moment, I guess, or about to get up. We could give him a call. No, there's Mike just here.
Yeah, he's based in the UK.
He's based in the UK. So basically, how the funding, how the ArduPilot funds are managed is for small staff, the normal running, I guess, of the business, so to speak, is managed between the three of us. So things like paying the bills, basically, or small funding proposals that are under $2,000 US. The three of us just discuss it. Is it a good idea? Not a good idea? And generally, we will form a consensus there. For larger expenditures, such as the budget for this event, we put that out to the full development team and get input, and basically put that to a team vote, where all I guess everyone has who wants to put forward an opinion or a suggestion can do so amongst the dev team.
There are around 50 people in the dev team at the moment who have voting rights.
Yeah. So what Josh is kind of referring to there is that we kicked off a discussion earlier in this year about bringing on an additional, I guess, part-time employee. At the moment, we have 5 of the developers funded part-time by the partners program, providing support to those partners. And there's about 100, or probably slightly over 100 partners at the moment, which is a huge number. And those 5 engineers plus Tridge and Randy and Pete Hall and a couple of others, Bill Guy, who contribute into that partner support program, do a huge amount of work. Because the partners program is, exceeding our expectations, it's wildly successful. We're in a position where we need to bring more people into that. Plus, we have the resources to do that. But we also need to balance that against the broader needs of the project. So ArduPilot is, it's a global community endeavor. It's not just about the partners. They're fundamentally important to us, but we also need to not just solve their problems, but set the project up for future success as well. So, does this next person we fund to work through the partners provided funding or partners and donors, there's also, community donors as well that contribute into the pool of funds, is the best use of that ability we've got to bring this new person on? Do we put them into supporting ArduPilot's tooling? So the built-in tests, test suite, Mavlink, all of those things that it's very easy for your general implementer user of ArduPilot to just assume exists, even though no one's really funded or sponsored to work on those things. Because it's really hard, I guess, to generate interest from industry in that lower level tooling that's invisible to most people. Do we pay someone to work on that part-time? Do we bring on another partner support engineer? Because the workload for the half dozen or so people that are doing that partner support is growing rapidly. Or do we start looking at other parts of the ArduPilot project and start doing more outreach or STEM or business development or marketing or something like that, that might grow the partners program a little bit more so that we can then bring on some more people to provide that support. At the moment, that discussion, there's an open email thread that Josh has kind of referred to in his question there. There's also some separate discussions with myself, Tridge, Randy, and the funding team as to what that might look like. There is a draft proposal and vote that is that some people have contributed to, but we're probably not at a position today to kind of make a decision as to what we want to put forward to the dev team, and then from there put forward to the partners in the broader community. That probably doesn't answer Josh's question completely, but it does give I guess a pretty broad overview of how the funding committee works, and how we're spending that money through the partners program, the support engineers, and what we're looking at doing next.
One thing I'm in favor of too that's been discussed a bit is a little bit more of a marketing presence. Like right now, everything's been done organically, and the engineers are essentially the ones doing the YouTube streams and posts on Twitter and all that. So if that was a bit more managed, intentionally as far as scheduled things and more proper announcements, that I think that has a lot of positive impact.
Yeah, so definitely, I'd love to hear some broader opinions on that. Tom makes a very good point. Engineers are really, really, really bad at marketing. And just managing, that public face of ArduPilot, getting not so much the message out there, but letting people be able to see and find, some of the cool stuff that's happening in a relevant kind of way and as fast as we can get it out there. So happy to take feedback, comments, questions, suggestions.
The comments and if we do market, we also have to bolster the support because it will, more exposure we get, the more people will come in, and we need to be prepared for that. That's all. Otherwise,
Scaling. Sorry,
I think that's called good problem to have.
Well, yes and no. Yes. So, and that's one of the challenges with the success of the Partners Program at the moment, in that program has been wildly successful, but it was based around accessibility. So the barrier to entry on the Partners Program is really quite low. It's $1,000 US, basically pay what you can afford, right? Which is a brilliant model, and it's worked brilliantly well for us. But it also means that we're constrained in the resources that it provides us. So with 100 partners, the revenue stream that's bringing in is substantial, but it means that the people that we're employing part-time as partner support engineers, whilst they're getting a stipend, if you like, we're not paying the market rates for that work because we can't afford to do that. So we're basically just saying, who's willing to volunteer some time and will offset the opportunity costs that you're taking on, if you're willing to help us out. And they get the partner support engineers get the benefit of exposure to real-time industrial and enterprise challenges, and we get the benefit of that getting fed back up into upstream ArduPilot and minimizing, I guess, the delta between or the fragmentation of those partners or users from upstream ArduPilot. So there's some massive benefits there. But if we grow too quick and partners generally join, with a relatively small contribution, and it's not until the second, third, or kind of when they resubscribe or year after year that they start getting comfortable with the value that program provides them, and therefore to contribute more into it, that we start being able to bring on more resources into that program.
And we greatly appreciate so many partners have offered a lot more than the minimum required. And it is fantastic. We've been able to do so much more in the project because now, in fact, the majority of partners, in fact, contribute significantly above what the minimum required is, which has been brilliant. Thank you.
And also, I just want to say, we've been a partner from the beginning of the Partners Program, the ArduPilot, probably CNC, Excel sort of as one. I just want to encourage other partners to appreciate the absolutely pathetically small amount of money this is for what you get. The people in this room are donating massive amounts of time. I mean, we employ engineers, we know what engineers cost. You get such amazing value from this team. So just want to encourage other people that may have a business that relates to ArduPilot, they're selling things that they profit through ArduPilot, they use Mission Planner, they use all of that. Join up, it is such a small fee and it's absolute wonderful value for money. One of the things we agreed at the very beginning of the Partners Program is it's not about the partners controlling it or anything like that. It's about showing appreciation for what this awesome team is doing. So
and we get a lot back from the partners, not just the financial support. A very large percentage of the new features in each release of ArduPilot stems directly from discussions we've had with partners, feedback, issues that they've hit. And because we are the support engineers, but also we are core developers, our natural inclination is to solve problems with code. And so a lot of the new code that comes in comes from somebody says they were having this issue with that device, and we say, let's fix that properly And that partner benefits, but then that rolls into the next release. And that's what allows it to snowball and really provide benefit to our people. So that feedback process and the quality of the feedback we get get flight reports with really detailed reports of what the pilot saw, what their expectation was, what the vehicle was doing, the logs, of course. That effort that partners are making in making really high quality reports to us, we greatly appreciate that. It is brilliant, and that is as valuable, in many cases, much more valuable than the financial contribution.
Yeah, but we do need the financial contribution.
We need both.
Yeah, that there's been a sort of recent trend where most partners actually want to donate at least a little bit more than what they did last year, which has been really great. And the second thing is that it's been increasingly easier for me to approach partners, and they're not giving me any trouble whatsoever and just wanting to contribute as much as they can. So personal thank you for that. And last with that, I wanted to say was that I raised a proposal for a social media manager. That was I uploaded a doc, and I think everybody agreed that we needed one. And I was holding on to that discussion till this point. So I was wondering if I should raise that to a vote or not. And I think all of us pretty much agree that that should probably go to a vote now.
Yeah, I might just step back.
Trying to avoid being in front of the camera for this. Seems I've failed. Yeah, so what we've drafted to put to the dev team, and I guess we could probably share it if we wanted to.
If I could find it right here, sorry.
But basically, because there's so many things we want to do right now, but we can basically only really, just because I'm quite conservative and it's not my money. Basically, what we're going to put up is basically pick two of these 3 or 4 options, and I can't remember if we put 4 options on the form or not. But that vote form is in draft. It includes that kind of marketing function as one of the options. And basically what we're going to put to the dev team is pick 2 of these. We can't do, they're all of these functions are important. We all agree they should be funded by the project funds, but we can't do them all right now. So let's prioritize them. Let's pick the first 2 up out of the list. And then in 6 months or 12 months, as the partners program keeps moving forward, and as we have more money to support the project, then we can continue building on that on the internal support program. So whether that's support engineers, whether that's industry and partner engagement, whether that's social media, whether that's tooling. And there's a few other things that are on that email chain if you go back through it. So we prioritized a couple of those, I guess basically amongst me, Randy and Tridge. We'll socialize that and then put the vote out. And that should happen in the next couple of weeks. We'd hoped to do it this weekend. We just didn't quite get there because we all got distracted organizing in Japan. Yeah, but yeah, so we don't want to put up that social media manager as a single proposal, just because whenever we put a proposal up that is do this or don't do this, like a binary decision, this dev team, I can only think of 1 vote that's gone negative in like a decade.
It's
and I don't want it to be a race between important functions. So we put them all up there collectively, and that forces the dev team to make that decision based on their own priorities.
Yeah, things need to be put together as a budget, not individual things.
Right.
Yep. Okay, so I'd like to get some topics from the audience about ideas, but there's one more that I thought of that I hadn't put in the list, which is about this conference. So this conference has been in Canberra for all the face-to-face ones for many years now. The previous 3 ones were online. There has been a proposal to break from that tradition and have it in the US. So I'd be interested in how many of the people here in the audience would be comfortable with the idea of a US-based conference next year. Pretty good proportion. Okay, so So I think, are we at the stage where we could say that this is pretty likely to go ahead? I haven't heard anything negative about the concept. Tom, would you like to say something about your proposal? We'll probably end up with a team vote on this. We have a process of voting in the team, but there's only one proposal on the table at the moment. And this proposal involves me not being the conference organizer. So I am going to be saying, yes.
You are required to be there though.
I'll come along.
All right. Yeah, so at this is Tom Pittenger from Krause and Downey Aerospace. We're basically proposing that we're going to host it in Reno, Nevada, in the United States. And it's we have a hangar at Reno Stead Airport, which is just outside Reno, where all the Reno air races are. So if you're familiar with the Red Bull and all those, those crazy planes and contests there. So it's a proper airport. You want to see what 30s there and stuff. So it's got like 3 different runway sections to proper airport. And they just built a whole new building with the conference room and whatnot. And they've had some crashes over the years, and it's getting, their insurance is going up, and it's just they've kind of decided that this is the last year that they're going to do the air show. So typically it's every September, mid-September, and they had declared this is the last one. So we put forward to them an idea of the following year, make it start over and do an autonomous drone air show. So let the make it kind of vendor agnostic and whatnot, but STEM oriented and all kinds of stuff. Let vendors come show off their stuff. So it's not just expo where you have a booth, it's an expo where everyone actually flies their stuff. Very, very outdoor oriented event. And so traditionally that's every September. So what I'm thinking is having a 2 weekend or a separated by a week somehow, where the ArduPilot conference is beforehand, and it's this sort of format where it's I guess the unconference or whatnot, where it's very developer tech oriented, and then the following week is the larger everyone can come kind of thing for exposition purposes. And but the big pluses to it is in the drone industry, there's been lots of I don't say gimmicks, but a lot of vaporware and just people promising more than what they can deliver. It'd be great to actually have it out there where everyone's out there flying it and they can show off what they have and show off what they can do, right? As opposed to just say they can. So but I'm seeing all the kinds of different races and all kinds of different ideas. Right now they have things like the stall stuff, STOL, the short takeoff and landing, where you got some aircraft that how fast can you get off the ground, or how land with how much ground you're touching, used to mount, stuff like that. All kinds of different ideas. So one thing about this airport is it's outside of Reno, about 15-20-minute drive from Reno International Airport, and it is north of Reno. And it's one of the 5 or is it 6 UAS test facilities designated by the FAA. And it hasn't been used a whole lot for that. And UNR, the University of Reno, is the custodian of the COA for that. And so we're in there doing our stuff now, but we're kind of bringing life back to the site for that. So they're really excited about doing all that. So we're actually for these air shows, they close down the whole airspace all around. So I'm not sure how it works for the rules as far as if remote ID is needed or whatnot. But there's going to be TFRs. There's going to be the whole place will be shut down, the airspace all around it, and they do it regularly. They manage all that. The FAA is all on board with doing stuff all the time with them. They have huge sponsors. It's a rather large event, and so we'd be able to piggyback on that, start something new with a large drone exhibition, and then have us sort of kick that off as a developer platform before it, and then maybe hackathon before that, and flies.
We'll see. Yeah,
who knows,
we're still discussing it, but
yeah. So the date's not set yet, but just typically the air show has been every September. So I presume that's the schedule it's going to be, but I'm not sure if I'm sticking to that or not.
Thanks, Tom. So that's what we're thinking about at the moment. If you come here, this time next April, then you may find that we're not here. Yeah.
Yeah, well, grow into that next competition, see to be to include the places as.
Yeah, we have actually had a few discussions with them, not on this particular topic, but related things. Yeah. Okay, so all right, so that's about it. I think we should now open it up to the audience to raise topics. So are there any topics that the audience wants to raise and put this group of, you know, likely looking people on the spot? Robert.
Hi all, Robert Moore. So I know we've had some talks before Tridge, but there have been a substantial growth in the bidirectional signal. So single signal wire, bidirectional signal telemetry systems like servos, ESDs and stuff from Jetty, Powerbox, FreeSky. I know it's as much a hardware as a software issue. So what would be good ideas for trying to bring some of these bidirectional communications online within ArduPilot potentially for telemetry feedback?
So yeah, good question. So we actually support quite a lot of bidirectional telemetry, RC bidirectional telemetry systems now. So CRSF and the like, you know, FPort2, and there's a whole bunch of them actually, about half a dozen. There's the people who've done the most work. Andy Piper's done a lot of work on this type of thing. Henry Wurzburg, so we do support a bunch of them already. We tend to add them when two things: when the hardware exists, and B, there is demand. And C, usually we like to have some sort of a specification, but not always. Sometimes we've reverse engineered protocols. And
it happens faster if the developer has the hardware.
That's right. It does tend to happen faster if the developer's got the hardware. So the Yapu, for example, with his, he's got multiple forms. With you're probably familiar with the Yapu telemetry scripts, which are a set of Lua scripts that run on OpenTX-based radios, and it supports multiple different types of bidirectional telemetry happening over RC systems. We also have various one-wire protocols. So like the classic is the FPort2, which is a one-wire bidirectional. There isn't like a single library that does them all, because each of them tends to use a different methodology. Some of them are framed by timing. Some of them are framed by header markers. There's different techniques for doing these types of protocols, but there already is several of them in ArduPilot, maybe half a dozen or so, and we're certainly open to adding more.
I guess maybe this is my ignorance as well. At least from my understanding, it's from the flight computer downlink to the, for example, the FPort2 on the FreeSky down to the transmitter. I didn't see the documentation essentially taking it from, let's just say, for the FreeSky system, an RV25 with the servos back into the cube. So
right.
Is that part there? Is it missing?
We do it, for example, bidirectional D-shot is an example of that. That's a one-wire system where we get the RPM back, and there's extensions that are happening to that to actually bring more than just RPM on that one-wire system. So where it would actually bring back temperatures and voltages and things at a lower rate.
FETEC one wire as well.
Yeah, the FETEC one wire is another example of that. We don't have the specific one that you've mentioned, but as long as there is a data sheet, then it is implementable, almost certainly. Depending on the data rates, there can be hardware limitations. It might, for example, require DMA in order to be able to get the reliability. Some of them can be bit banged. So we do support some protocols that are bit banged bidirectional. They're much lower data rates, and they're a lot more flexible in terms of what hardware. So there are several examples of that where it's coming back from a device. We don't specifically support the one you're talking about, like the FR Sky temperature sensors, the FR Sky RPM sensors. I have looked at those in the past, and it is perfectly doable. Particularly now we've got the faster CPU. It is a perfectly doable thing, but it just has to be implemented.
Request welcome.
Oh, good. Any more questions from people from the audience? Or have we worn you out?
I'll just do a quick scan of,
Okay, all right. So for later this evening, many of you are going to be catching flights tomorrow. Some, of course, might be, you know, rushing to the airport straight after this talk is finished. But I think most of the people who are flying out today have probably already, you know, gone out to the airport or whatever. For those of you around this evening, I was thinking about possibly going up to the top of Red Hill Lookout and maybe having Turkish pide or something like that up there if people are keen on that. Another possibility is going somewhere like the Carillion, which is a small island in the lake, and again, having takeaway there. Or we could all just disperse and go our own ways or go back to our rooms and sleep, and because we're all exhausted. What are people's thoughts? How many people want to do something social together this evening? We could indeed move on to that if we're done. Any more questions from the YouTube that we're done?
There's a specific question about gimbal roll. There's a question for Randy. Could the gimbal roll and servo control in range finder or depth we combine them? That's from John Easton and Michael, so that we that's diverted into the forum rather than taking this one down.
Well, I think the answer is probably, but need more details.
Great answer.
Tim McLean asks, any thoughts about a mission complex structure approach? There's no more detail on that.
I can't quite pass
Well,
that. Sorry, Tim.
Well, so as far as complex, the jump tags kind of enables that a bit. I've talked with Michael
Okay,
a bunch about
potentially.
that.
Assuming, depending on exactly what Tim
I'm
means.
interpreting, yeah.
Yeah, so
Yeah.
is added a basic string structure, which doesn't have any parts that.
No, we might need to follow up with Tim
Yeah.
later.
So both John Easton and Tim, please answer those questions in discuss.onlyfy.org.
Or on the Discord channel, appropriate one. Yeah.
Yeah, there is
Okay.
one that I want to mention about the jump tags, though. I think that's gonna be a big game change once we.
Speaking of microphone.
Yeah, so there's a new feature called the jump tags that's kind of a big deal. It's gonna allow us to do like submissions and whatnot.
Yeah.
Where you can jump to a mission and not actually know what the index are. Or the indexes makes it a lot easier to do mission complicated things without the script from the script without the script actually knowing the mission. It can just kind of jump to a point, so it's tagged in the mission. So look out for some features of that in the future.
Josh Anderson's got a couple of other questions. The larger one is supporting old releases with important bug fixes. So basically backporting.
That's a real chestnut, and it's something that Peter and Randy and myself in particular have been discussing about how we manage. There's a technical barrier at the moment with the way our build server works, which we think we can overcome relatively quickly if we lock Peter in a room for a few hours. And many things can be overcome with locking Peter in a room. So as your kids, I'm no doubt would attest. Yeah, we do want to do a better job of getting fixes into older releases. And Josh makes the very valid point on the chat about like 4.2 is only, a bit over a year old. And yet we're already not doing backports of bug fixes to 4.2. I have in fact created, for example, that recent BD shot bug. There is in fact a backport of that to 4.2, which I've put up on GitHub, but we haven't done it as a new 4.2 release, which can be downloaded via the standard, for example, Mission Planner installation system. I would like to do that, and we're working on the mechanics of convincing our build server to do that. So hopefully you'll see that in the future, we will be able to do those critical bug fixes going back to much older releases than what we can at the moment.
Since you're speaking to the build server, can you make it run faster too?
Yeah, it's already got a pretty beefy CPUs, and we have put a lot of effort actually in making it faster, but we keep expanding the number of flight controllers we're supporting and the number of different builds and things. And so the work it has to do keeps growing at a very high rate. And which is a good problem to have. It's great to see all the new flight controllers and new vendors and things and new new targets. But we'll just keep beefing up that build server. All right, so we might actually just now thank our audience, remote audience, and thank you to all the people who've been, staying up late, shout out to Louis and Craig and Tim and many others who've been providing great feedback and questions on the via the live stream. Thank you. And we've already had a lot of views of the live stream recordings we've done, and I'm sure there'll be many more. The videos themselves, the first edited video, many thanks to Louis for volunteering once again to doing the editing of the ArduPilot DevConf videos. He's got the first video up there now, which is Paul Riseborough's Tech's video is up there now, and he's working hard to get them up. It is quite challenging because Randy and myself have the occasional mistake, well, perhaps more than occasional mistake in the audio recording and things, which gives some frustration for Louis. But and my apologies for stuffing up the first few minutes of Randy's talk, not having the microphone on. That was completely my fault. Please enjoy the videos. They will be appearing, the full set of videos, over the next few days, and hope you enjoy them. So we might say goodbye to our audience. Goodbye, everyone, and see you at the next Dev conference. And